Hey folks, I just got out of seventh period maybe 30 minutes ago, and I thought I would just get started on this video. So for those of you that want to try and attempt the homework, that you at least had some examples. So before I move on to any examples, I really just want to take a minute to look again at the definitions I give you, all the different speeds, and then those conversions. If you didn't have enough time to write it down in class, I would say pause the video here, write this down, make sure you have it on your note sheet. I think this is going to be really helpful for your work on your homework the next couple of days. So if you need to, pause, and then you can, when you unpause, I'll be doing some examples. Okay, so for the rest of us, if you are coming back off a pause or if you just kind of went through, let's take a look at how this is going to go. So for each of these, I'm going to write the goal of where I want to be so that I have a really clear idea of what I'm working towards. So if you take a look at the first example, I already have for us the 10 revolutions per 1 second because that's given. Notice it's a rotating speed. So that's our rotational speed. Now, the question's asking for the velocity of a point on the rim in meters per minute. So that's a linear speed. So that's what we think of as like miles per hour. So somehow we have to go from a rotational speed to a linear speed. So think of this as this is where we kind of our starting point, and this is our end goal, where we want to go. All right. So let's see what sort of information we're given. Well, it looks like the only other thing I see is a 12 centimeter diameter, which doesn't feel very helpful. And it also isn't helpful that it's a diameter. So I think, first of all, I'm just going to write down here 6 centimeter radius, because I know I'm going to have to deal with the radius. By the way, if you hear any sort of construction sounds in the very faint background, I think my neighbors are getting a new garage door. So I apologize for that. But that's what's going on in the background. Okay, so revolutions per second. And we want to get to minutes. Oof. All right, so let's sort of think about where we're at this point. Revolutions per second, we need to turn the revolutions into radians. So one of the conversions I gave you was that 1 revolution equals 2 pi radians. So that means our revolutions are going to cancel, which is great. So now we're in radians per second. And if we were to multiply across, this would be 20 pi over 1. So radians per second. Hey, that means we're in angular speed. Just by multiplying by that, we got to angular speed. So I think the next thing I want to deal with is the fact that we're dealing with seconds. So let's try to get rid of the seconds. So 60 seconds, and I'm putting it upstairs because I'm going to want to cancel with the downstairs second. 60 seconds is equivalent to 1 minute. So now I'm looking at radians per minute. Okay, so I'm getting to the per minute, which is great. But now I have to think about how am I going to get meters involved in here. So that's where I have to pull in this radius length. So remember, one of our key conversions was length of radius over 1 radian. So I'm going to put that in. I'm going to put in the 6 centimeters per 1 radian. So now my radians are canceled. So now I'm in centimeters per minute, and I want to be in meters per minute. Shoot, so close. So one of the other conversions I gave you was that 100 centimeters is equivalent to 1 meter. So centimeters now cancel, and we are in meters per minute. Okay, so what in the heck do we do with that? Because doesn't feel like an answer, even though we are close to getting our answer. Well, I'm going to take all the numerators and multiply them, and take all the denominators and multiply them, and then divide those two numbers. So what I'm looking at then is I'm looking at 10 times 2 pi times 60 times 6 times 1 all over 1 times 1 times 1 times 1 times 100. So if I pull out my calculator, I'm looking at 10 times 2 pi times 60 times 6, and then, okay, so this ends up being, the numerator is 22,619.467, because there's no nice way around that, divided by 100, because 1 times 1 times 1 times 1 times 100 is just 100. And this is in meters per minute. So if I divide this by 100, I'm going to get 226.195 meters per minute. So it should feel, for those of you that has taken chemistry, really just feel like we're doing the factor label. All right, let's try the next one. So Mr. Nash's bike has tires with a diameter of 32. Oh, I hate it when they give diameter. I always want to write in the radius here, 16 inches. Okay. Because a big mistake I usually make is I usually end up putting in the 32, getting the wrong answer, and then wondering why in the heck is this wrong. So suppose Mr. Nashin is riding his bike and the tires make 3 revolutions per second. Okay, so what's the rotational speed? Well, it's actually given to us in the problem. It is 3 revolutions per 1 minute. Okay, so that's not too bad. Next says determine the angular speed in radians per second. Okay, so our goal, so let me write this in a different color. Our goal at the end is to have something in radians per second. Okay, already I see a little bit of a trouble because, oh wait, radians per second. Whoa, did I do that wrong? I did. Go back up here. I was seeing an issue because we had minutes. I did not read this properly. This should be seconds. Okay, so phew, we don't have to worry about converting between seconds and minutes. Not that that's terribly hard, but it's just something else to do. All right, so I'm going to start with that 3 revolutions per 1 second. And I want to get rid of the revolutions. So that means 1 revolution, so those will cancel, per 2 pi radians. And hey, then we'll be in radians per second. So let me multiply across. I end up getting 6 pi over 1, and this is radians per second. So you could think of it like this, or if you want to, you can take pi and multiply it by 6, which is going to get you 18.8, let's see, 85, it looks like, if we're rounding properly, radians per second. Okay, next one is linear speed. So linear speed, our goal is to get to inches per second. So you want inches per second. Nice thing is we're sticking with the seconds. So now we have to get to inches. So we're going to pick up right where that last one left off. So we're going to pick up with that 6 pi radians over 1 second. And we want to get rid of the radians, right? So 1 radian, that conversion goes to the radius of the circle, which, let me scoot back up, our radius is 16 inches. I'm going to call this 16 inches up here. These radians are going to cancel. Now I'm in inches per second, so I just have to do 16 times 6. So this is looking like 96 pi radians per second. So this could be my answer. If you wanted to, you of course can multiply that 96 by pi, and an approximate answer would be 301.59, and that should not say radians, inches. This would be inches per second. Sorry, folks, for all the little mistakes I'm making. There's a lot of details to cover. Okay, last part for this problem asks how fast is that in miles per hour? So this is truly just a conversion. We could have done this even probably freshman year when we were sitting in Algebra 1, because we knew how to convert between a lot of these units. Okay, so 96 pi inches over 1 second. So it does not matter what you do first. You can deal with the inches or you can deal with the seconds. You have to get to miles per hour. I find unit of time just easier to deal with. So I'm going to go with 60 seconds converts to 1 minute. And then 60 minutes convert to 1 hour. Okay, so now we're in inches per hour. So now we need to get rid of the inches. So we do know that 12 inches are in 1 foot. So that gets us into feet per hour. And we also know that 5,280 feet are in 1 mile. Okay, so now I'm going to take that 96 pi, or that 301.59. I'm going to multiply it by 60, and then multiply it by 60 again. The 1 and the 1 don't really matter. And let's see, what do I have down below? So I'm going to divide by 12 and divide by 5,280. And I end up getting actually not a bad number, 17.14 miles per hour, which for my drivers, you know that that is really slow. But for a bike, it's not too bad. So I'd say this problem is a pretty good evolution of the different things you're going to be asked about. Notice it starts with rotational speed, moves to angular speed, moves to linear speed. It kind of shows you in each of the first 3 parts how one builds upon the other. And then the last part here is really just taking a look at different conversions. All right, so I hope you're doing okay. Looks like we have a few more problems to do, so let's keep trucking. Again, if you need to pause and rewatch something, do it. There's no shame in that. All right, lawnmower blade has a radius of 9 inches. Oh, thank goodness, we're given a radius. And the tip is traveling at a rate of 45 inches per second. Ooh, 45 inches per second, that's a linear speed. So we might be going backwards, my friends. And in fact, we are. So rotational speed is, so remember our goal over here. Right. Our goal is going to be for rotational speed, revolutions, in this case, per second. So let's take a look and see what that means. We have 45 inches per second. So the second's okay, we just need to get to revolutions somehow. So we need to cancel the inches. So that means I'm going to do 9 inches is to 1 radian, not revolution. Thinking ahead. And then if you think about our circle, 2 pi radians is going to give us 1 revolution. So if I multiply across, I'm looking at revolutions per second, which is where I want to be. And I end up having 45 revolutions per 18 pi seconds. Yeah, it doesn't make a whole lot of sense, right? This is kind of a weird thing. And if you wanted to, I guess we could reduce the 45 over 18 and make that what? So both divisible by 3. So we can do what? 15 over 6. Oh, they're both divisible by 9. Hold on. So it could be 5 over 2 pi. So let's see. Let me figure out how to type this in my calculator. 5 over 2 pi. All right, I think I figured it out because I'm using kind of an older calculator. So this should be 0.796 revolutions per second. So not a complete revolution in 1 second, but maybe 80% or so. Okay, let's take a look at part 2 of this problem. Now we want an angular speed. So angular speeds are radians per unit of time. So this is going to be radians per second. And so let's take a look at what we have. So I'm going to start, so I think I'm just going to start back with that 45 inches per second. And I want to get to radians per second. So I'm going to multiply that 1 radian, kind of the same conversion I did up here, over 9 inches. And lo and behold, I'm in radians per second. So I get 45 radians per 9 seconds, which actually just turns out to be 5 radians per second. This going backwards thing isn't as bad. Okay, if you need to go back over those, pause the video or rewind the video and take a look. I'm going to move on to problem number 5 and 6. So 5 and 6, when I see no parts, I know that I'm going to have to do all those parts that were broken apart in the previous problems. I have to do it all at once. So this can feel like a lot, but if you just use that factor label, it's not too bad. Okay. So first thing is we're given 12 revolutions during a 3-minute ride. Okay, so that's good to know. And the diameter, stinking diameter again. So let's write radius equals 15 feet. Okay, so we want Harriet's linear speed in miles per hour. So let's write our goal over here. We want miles per hour. So we're probably be doing a lot of conversions here. So let's start with the first sort of speed we know, and that is 12 revolutions for 3 minutes. Okay, so we can either work with the revolutions or we can work with the minutes. I find it easier to deal with the units of time first. So I'm going to say 1 minute is, that's backwards, not seconds. Hold on. I want 60 minutes is to 1 hour. Okay, so now I know I'm in hours. So I'm in revolutions per hour right now. and I want to get to miles somehow. So revolution, for one revolution, I go through 2 pi radians. So that cancels out my revolutions. Okay, so now I need to get rid of radians, and I need to put it somehow into miles. But I'm only given that radius of 15 feet. So I'm going to use the 15 feet to 1 radian. So that the radians cancel, and now I'm in feet per hours. Okay, so I know that 5,280 feet are equivalent to 1 mile. And now if I look at what's left, I have miles per hour. So I'm going to multiply across. So my numerator is going to be 12 times 60 times 2 pi times 15. All right, let me keep that in terms of pi right now. So 12 times 60 times 2 times 15. So that's 21,600 pi miles, which is very odd, over basically 3 times 5,280. So over 15,084 hours. Okay, now that's pretty weird, right? So let's get this as a decimal. So we have 21,600 times pi, and we're going to divide that by 15,840. This is approximately 4.28 miles per hour, which probably makes a whole lot more sense to folks. If you think about it, a Ferris wheel doesn't go that fast, so a little over 4 miles per hour should make sense. Oh man, we have a number 7. I didn't see that hanging out down there. Shoot. All right, let's keep going. A car traveling 35 miles per hour, okay, so that's a linear speed, has a tire with a radius of 15 inches. Oh, thank goodness it's a radius. We're going to find angular speed in radians. So let's do our goal is going to be radians per minute. Okay, so already I can tell I'm going to have to do some converting because we have miles per hour. So hours and minutes, those are going to be different. All right, so let's start with this 35 miles per 1 hour. As I've told you, I like to start with converting the time. So 1 hour is 60 minutes, and now I'm at least in miles per minute. Okay, so miles per minute. So the miles I have to start getting away from. So let's see. This is inches. Shoot. So I can't convert miles straight into inches. I have to go from miles to feet, feet to inches, and then I can bring in that 15. So this is definitely a tricky one because my units don't match at all. So I'm going to think of 1 mile, and then I can cancel those miles, being 5,280 feet. And then 1 foot, so I can get to inches, it's 12 inches. Now, why the heck is that helpful? Remember, I'm trying to get to radians per minute. So I need to get rid of the inches by multiplying. I'm going to have the radius down below, because what that'll do is cancel out my inches. And then that 15 inches is equal to, or equal to 1 radian. Remember, we had that conversion right there. What I'm using is, let me back it up, this conversion right here, length of radius per 1 radian. So that's what's going on there. Okay, let's multiply across. Whew. Luckily, there's no pi's involved, so that's good. So in the numerator, I have 35 times 1 times 5,280 times 12 times 1. So this is, holy cow, 2,217,600 radians per 1 times 60 times 1 times 1 times 15. So divided by 900, it looks like minutes. Let me actually divide those numbers. That 2 million number divided by 900 is going to get me 2,464 radians per minute. That's spinning pretty fast. If you think about it, one revolution is 2 pi, which is about 6.28. So this is going much, much faster. All right, looks like we're on to our last example problem here. I hope you'll find these helpful. Again, I think really the most helpful problem is what we did in number 3 here, because it really takes you through angular and linear speed. Well, let's take a look at 7 with the lawnmower blade. It has a diameter. Gosh, I hate that. I immediately write 9 inches for my radius, cut that in half, and it turns at a rate of 1,300 revolutions per minute. Okay, so we are trying to get to a linear speed. So let's write our goal over to the side. Our goal is feet per second. Feet per second. All right. Oh man, and we're given inches. This is lots of converting, it looks like. So let's start with what we have. We have 1,300 revolutions per 1 minute. I tend to start with time, so I'm going to get rid of that minute and say that in 1 minute, I have 60 seconds. Okay, so I know I have the seconds, so now I'm going to start thinking about revolutions. So in 1 revolution, I have 2 pi radians, and 1 radian will give me this radius, 9 inches. So if I look at the labels that are left, I'm in inches per second, and I want feet per second. So I'm going to have to get rid of inches. So 12 inches is the same thing as 1 foot, and now I'm in feet per second. Okay, so let's multiply across, and I know it says round to the nearest foot. So our numerator is that 1,300 times 1 times 2 pi times 9 times 1. So that's 23,400 pi feet over 1 times 60 times 1 times 60 times 1 times 1 times 12. So divided by 720 seconds. Now, that is an awful answer, and it says to round to the nearest whole foot. So what I'm going to do is type in my calculator that 23,400, multiply it by pi. I get like over 73,000. If I divide that by 720, I end up getting 102.10, and it says to the nearest whole foot, so we're going to say 102 feet per second. All right, I hope that helps. Remember, videos are awesome because you can always rewatch them to get help. You can pause them. I find them very, very helpful when I'm studying. So I'd say the most important example problem, I can't stress this enough, is number 3. It really takes you through everything you need to do. And it takes you past a little bit by doing that conversion in the last part there. So I hope you found this helpful, and you have 4 homework problems due by Friday. That would be on page 262, numbers 97, 109, 110, and 113. All right, folks, I will see you Friday. Have a great week. Good luck on the SAT if you are taking it tomorrow. Bye-bye.